Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models, they just launched dedicated CPU instances. And they also have a new object storage service to make storing data for your apps even easier. Go to pythonpodcast.com/linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, ODSC, and Data Council. Upcoming events include the Software Architecture Conference, the Strata Data Conference, and PyCon US. Go to pythonpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host as usual is Tobias Macy, and today I'm interviewing Alex Grönholm about APScheduler, a library for scheduling tasks in your Python projects. So Alex, can you start by introducing yourself?
Yeah, sure. I'm a long-time developer doing hobby projects and commercial projects for many years. I think my professional career mostly started around 2005. I didn't start with Python. I actually started with PHP and then went on to Java. And then I think Python was the next language.
And do you remember how you first came across Python?
I remember one of my colleagues mentioning it in passing, but that didn't spark my interest. It was only after quite a few years that I was reintroduced to Python. I don't remember when that was exactly. I do remember I started using it in my work projects in around 2007, I think. I needed to find a new tool besides Java, and then I remembered Python, maybe because it was already gaining a lot of popularity. I heard a lot of good things about Python, and then I wanted to try it out. I made my first practical application in like a couple hours after starting to learn it. It was that intuitive. So I fell in love with Python, and I still am in love with Python, I would say.
And given that you have a background in a number of other different languages, do you find that you still use those other languages for some of your different projects, or are you primarily just using Python these days?
I'm primarily using Python these days, and pretty much the only other language I use is ECMA script for practical reasons, because it's the only one you can use on the web right now.
Yeah, it's interesting that JavaScript has taken such a hold on the web, but I'm curious to see how things play out once WebAssembly gets to be a bit more mature and tooling makes it easier for us to be able to actually write Python modules to deploy to the browser.
The thing about WebAssembly is that Python is not a really good fit for WebAssembly, mostly because WebAssembly currently doesn't have garbage collection, but that's a whole another topic.
And so in some of the work that you were doing with Python, apparently you found the need to be able to schedule different tasks. So I'm wondering if you can just give a bit of background about what the APScheduler project is and some of the primary use cases that it was designed for.
The primary reason why I chose to write it is because there weren't very many options for scheduling tasks for Python at the time. There was the Celery project, but that was quite a bit of an overkill for what I had in mind. I was running this commercial project, a custom ERP software that needed to perform some routine tasks on the schedule. And I didn't want to use the cron daemon because it was not really the right tool for the job. So I figured this shouldn't be that hard, and I wrote the cron trigger and a couple others and published it as a public project after that. And it turns out other people were also looking for lighter scheduler, because the problem I usually get told about Celery is that it's very hard to set up, very heavyweight. So people come to APScheduler because it runs within your application and not as a standalone service.
Yeah, there are definitely a number of cases where, as you said, Celery is overkill for doing some lightweight projects. And I actually came across APScheduler a number of years ago when I was first starting to use Python in my professional work, and was pleased with the simplicity of getting it to run because I just needed to write a simple daemon that would execute periodic tasks and didn't need for the distributed capabilities that Celery brought along. So I was glad to find the work that you did so I didn't have to do it on my own. So for somebody who is going to build something on top of APScheduler, can you just talk through some of the workflow for integrating it into an application and some of the design considerations that they should be aware of as they're planning out the overall structure of their project?
Yeah, this is actually one of the pain points of APScheduler because the most common type of application out there is a web application. And usually in a web application, you have several processes running the web application as multiple workers to distribute the load. And APScheduler was really designed to run in a single process. So if you want to use APScheduler in a web app, then you need to be aware of the fact that it currently doesn't have any mechanism to share job stores. It says so in the frequently asked questions section in the documentation, but it is a very common problem. People want to use it in a web app, but there are some ways to do that. The first and foremost is to not use a persistent job store, but that may not work for everybody. If a persistent job store is required, then the only real way to do that with APScheduler 3, the current release, is to run it in a separate process and use some kind of RPC mechanism or maybe a lightweight HTTP server to schedule the tasks. So to build some kind of remote control interface for the web app. I recall there are some libraries that actually do that. I can't remember their names offhand, but they do exist.
Yeah, in the documentation, you have a reference implementation using RPyC for a simple command and control mechanism. And so it's definitely interesting where, as you said, a number of people who are thinking about task-oriented workflows are probably coming from the web where they're familiar with Celery versus people who might be building some sort of system daemon that just needs to be able to run periodic tasks on a server somewhere. And so there are different constraints and different considerations in those workloads where for web applications, as you said, it's common for people to scale horizontally across a number of instances. And so you need some sort of coordination mechanism versus somebody who's running a local daemon where all it has to care about is the local system resources, in which case APScheduler is a perfect solution.
In fact, the first use case that I had, my own, just involved one process. So it wasn't a problem in that setting. So regretfully, APScheduler was never really designed for horizontal scalability, but it's something that I'm already working on. We can talk about it in the end.
Yeah, when I was looking through the documentation, there's a lot of pluggable capabilities within the library, so it definitely seems that you designed in room for being able to add those capabilities without locking yourself to that at the outset. And so I think some of the design of how you structured the library definitely allowed for that eventual progression towards something more sophisticated while still being able to be simple enough for somebody to get something up and running in a single process and solve their needs in that use case.
Yeah, people use a lot of backing data stores, and I received quite a few PRs for adding new data stores. I think at least Zookeeper and RethinkDB were completely contributed up by other people. So that was a plus. It was really nice to see people interested enough in the project to contribute to such ready-made modules for APScheduler.
And so can you talk a bit more about how APScheduler itself is designed and some of the evolution that it's gone through since you first began working on it?
Yeah, the project is so old that I don't remember the design alterations in the beginning, particularly between 1.x and 2.x. But at least one aspect that I remember from APScheduler 3 is that before that, APScheduler was not really designed for a lot of jobs in a backend data store. So APScheduler 3 contains quite a few optimizations to make it work with thousands of jobs. Beyond that, I really can't recall. I've been trying to make it more modular, more adaptable along the way, but I still have ways to go.
And in terms of the scheduling algorithms that you've built in, what are some of the challenges that you faced in terms of being able to support the different styles of date-based versus cron-based versus interval, and then have combinations of those, and just some of the learning curve that you've gone through while you have been working on building and evolving the project?
I would say that the cron triggers have just given me the most trouble. Sometimes I would just stare at the code for half an hour trying to wrap my head around the logic. There have been some edge cases, particularly around daylight saving time. I'll just have to say that DST can go die in a fire, but it's a fact of life that we still have that. So some people have pointed out problems with the DST handling, and I think I've fixed at least the majority of the issues with that, hopefully. Nobody has complained about it recently, at least. Yeah, then there are some cases where the user can enter cron specification that will actually never trigger, and that can cause an infinite loop, causing the scheduler to pretty much freeze or go to a busy loop that never ends. And I'm not even sure what the proper solution to that is. Maybe limit it to a certain amount of iterations or whatnot. I'm not really sure, but it's a design challenge. Also, the OR trigger is fairly nice and doesn't usually give any trouble, but the AND trigger is very problematic, particularly when combined with the interval trigger. You see, the biggest issue with combining these two is that the interval trigger starts on certain second or millisecond, and then the trigger compares the produced next fire times exactly. So the trouble is that usually the interval trigger and the cron trigger never agree on a common fire time. So this also causes the scheduler to freeze because it keeps looking for the next available fire time, which is never found. There's a fix coming for that in the next major release, but it has given me a lot of trouble. I've answered several Stack Overflow questions regarding this very problem, but people keep encountering this problem. It's regrettable, but this is one of the biggest design challenges that I've faced with APScheduler.
Yeah, I don't envy you being so involved in a project that is so closely coupled to time and the way that computers deal with it, because as anyone who has ever had to deal with it before, time is one of the more challenging aspects of working with computers and getting anything right. And that's why there are so many different conflicting truths about how to handle it properly.
Also, the issue of time zones. APScheduler currently requires PyTT time zones because, particularly with the cron trigger, you have to have PyTT time zones for time zones that do have DST. So even if you use like plus 0200 time zone that you currently are using, then to a lot of people it came as a surprise that the schedules can be 1 hour off because they haven't taken into consideration the DST issue. I remember this one person who complained that their schedule was 1 hour off, and when I inquired further, they told me they were using Eastern Standard Time as their time zone, but it was wrong because they were actually somewhere on the eastern US seaboard, and they should have used the America/New York time zone because that will take care of DST when you enter the cutoff date time. But if you use Eastern Standard Time, then it keeps a standard a fixed offset, which is of course wrong at some point. Daytime handling is really a big can of worms.
Absolutely. And so in terms of the ways that you've used APScheduler, you said that when you were first building it, it was for an ERP system. I'm assuming at this point that you've moved on to other projects.
Yeah.
And I'm curious how much of a role APScheduler has played in some of the other projects that you've been involved with since then.
Well, I'm embarrassed to say that I don't really use it in production myself, but I anticipate that I will be using the next major release in production because I do have a need for a scheduler, at least for a periodic scheduling of projects. But for simple use cases, just a sleep loop is enough. In fact, a lot of people have asked about AP scheduler for their use cases, and when I ask, they just need to do something on a fixed period, and I've told them that if they don't need any sophisticated event listening mechanism or error handling or whatnot, they can just get by with a sleep loop.
And has the introduction of Async IO as a core primitive in the Python runtime brought about more interest in APScheduler because of the fact that there is a greater possibility of actually having the asynchronous offline tasks co-located with the primary runtime? And has that brought people into using APScheduler within those types of projects?
I wouldn't say that Async IO has had much effect on that, but Async IO support is one of the weak points actually of APScheduler, one that is going to be rectified with the next major release. Async support was pretty much an afterthought with APScheduler's design. That is going to totally change with the next major release. I'll talk about that later. But so far, the Async IO support is not nearly as good as I would want it to be. So I've actually refrained from using it myself.
And so, given that you aren't using it in production, what is your motivation for continuing to evolve and support the project after so many years?
Well, I don't want to leave people hanging, and it has been a great learning experience for me. I've learned about modularity a lot. Plus, it's a very popular project. I think it's somewhere in the maybe top 50 or maybe at least in the top 100 of PyPI's most downloaded projects. So it would be a shame to just leave it without a maintainer.
And do you have any strategies as far as making it sustainable, or is it just a nights and weekends project that you work on as you have the time?
Pretty much so. Nobody has volunteered to take over, so I'm just continuing it whenever I have time. Also, I should mention that Omer Katz of the Celery project has expressed interest in incorporating AB scheduler into Celery. It's interesting. Celery is, from my viewpoint, is pretty much a task queue with some minimal scheduling capabilities, while AB scheduler is primarily a scheduler with some minimal task queuing capabilities. And in fact, I approached them years ago trying to get them interested in incorporating AB scheduler to Celery, but they didn't express any interest in that at that point, at least.
Yeah, I've used Celery for a while, and while I was preparing for this conversation, I actually went and looked through their requirements list to see if APScheduler was used at all because of the fact that they do have some scheduling capacity with their Celery beats, and I was a little surprised to see that they didn't actually leverage that. So I think that that could be a good union of projects to improve some of the capabilities of Celery because I know that beats is one of their weak points.
Mm-hmm. So I've learned that Celery 5 will also come with some major internal changes, such as better high availability. And to accommodate that, they have requested some changes to APScheduler, which I am happy to provide. We can also talk about that at the end.
And so, in terms of some of the other uses of the project and some of the community that's built up around it, what are some of the most interesting or innovative or unexpected ways that you've seen it used? And how has the overall community reception and growth been for you as the maintainer of the project?
Well, it has been very encouraging to hear about all of the different use cases. People don't usually really give me the details of their projects because they are often closed source commercial projects. But I've learned bits and pieces from here and there. I think the first interesting point that was brought up was when somebody told me they were scheduling thousands upon thousands of jobs at the time. This prompted the optimization for APScheduler 3. But also, I remember this one use case where they were trying to set up a system that would allow different users to dynamically schedule jobs for themselves, but to keep different users separate. I'm not sure if that project went anywhere because APScheduler doesn't really accommodate such a use case. I would really like to support that, but it's a very difficult design issue. Apart from that, I don't really recall any specific project or use cases that might have been noticeable.
And as you have grown and maintained the project, and as people have used it for their own particular projects, what are some of the features or capabilities that have been requested, which you've consciously left out or pushed into other projects that wrap or take advantage of APScheduler or integrate with it?
The fact is, I don't remember. There have been a few requests that I outright turned down, but I can't recall the specifics, and I couldn't easily find them on the bug tracker. But I tried to be as accommodating as possible. But some of these features were very specific to their use cases. So I wanted to keep this maintainable, and with so many vastly different backends, it would be very difficult to support these use cases. I'm sorry I can't be any more specific than that.
That's fine. For such a long running project, it's entirely expected that different details will fade into the background, and it's impressive that you've kept it going as long as you have. And in terms of some of the design strategies or features that might often be overlooked or underappreciated, what are some of the things that you think users should be more aware of or would be able to benefit from digging deeper into?
I think that might be the use of setup tools entry points. You see, APScheduler has these setup tools entry points declared for different triggers and job stores and executors. So that makes APScheduler extensible in such a manner that you can declare these entry points in your own project, and you can then use the add job store and so forth, and use names of your custom triggers or job stores directly with APScheduler. It will just look up the entry point dynamically, and then it will just work. Also, a lot of people seem to have very specific requirements for triggers. Most of these use cases can be handled with the new combining triggers, but in other cases, I have told people to write their own trigger classes. And for some very specific use cases, I still recommend that.
And have you had people do something like build event-based triggers so that it's less time-based but still is able to take advantage of the rest of the capabilities of APScheduler?
In such cases, you don't really use triggers, but because triggers are solely used for calculating the next fire time. So if you want to build a reactive application that schedules a task for execution right now, then you don't really want to use triggers for that. You can just use APScheduler as a task queue, but you have to build that reactive mechanism some other way.
And in terms of your experience of building and growing the project and the community around it, what have you found to be some of the most useful or interesting lessons that you've learned in the process?
I think it mostly revolves around modularity and API design. API design is a very complex issue, very difficult, because you have to anticipate a lot of the use cases. That's the most difficult part in this. Yeah, also, I'd like to mention this one issue where a particularly angry user came to me complaining that all of their jobs have disappeared. This was because of partly a misuse by the user, but also a design problem with APScheduler. They had scheduled a number of jobs, and then they were using APScheduler from a totally different process that didn't have the same code base, and we're trying to gather a list of jobs. Now you see, when APScheduler is trying to deserialize the jobs from persistent data store, it tries to look up the job, and if the job function isn't found, the job is discarded. It was built this way so as to get rid of the jobs that are no longer relevant. But in this case, well, it was quite undesirable, and this user was very cross with me. Well, I don't blame them that much. Of course, they were misusing the schedule, but I don't blame them for not knowing what would happen. It's regrettable, and it's something I plan to fix in the next major release.
And so, looking forward to what you have planned for this upcoming release, what are some of the new capabilities or new evolutions of the project that you're working on currently?
The number one feature for APScheduler 4 will be high availability. Finally, the ability to share job stores between different schedulers. So you can have this web app and a scheduler running in it, even when using multiple workers. The scheduler will know how to communicate. Basically, it means that when the scheduler looks for the next schedules to run, it will obtain a lock on these schedules, and then other scheduler will know not to try to process them. So it's a partial redesign, a major redesign, I would say, that considers high availability from the ground up. That's the biggest feature. As for the rest, I intend to fix some of the design issues with the triggers. Right now, the plan is to make all the triggers stateful. One of the biggest reasons for that are the combining triggers, because the way they work right now is a bit difficult, because when you have multiple triggers inside an AND trigger, it doesn't keep track of what kind of runtimes they have produced. So it can give you some unexpected results, and that's something I intend to fix with the next release. Also, there will be a threshold within which the fire times have to fit, so they don't need to be exact matches anymore. Yeah, there was also one design issue with the cron trigger. I think the weekday numbers didn't really match the cron specification, but I couldn't fix that in 3.x because it would have caused unexpected behavior for people who have already worked around this problem. Yes, and there will be better async support across the board. All of the job stores will be asynchronous, and a blocking scheduler will be provided, but behind the scenes, it will use async.
And in terms of the async capabilities, you mentioned that there is some support for it, but it's not as fleshed out as you would like. And I know that in the past conversation that we had about the Asphalt framework, I think almost 3 years ago at this point, you were using APScheduler and that, where Asphalt is primarily based around asynchronous networking. And so I'm curious how much of the design and integration of APScheduler with the async runtime was driven by your use case of building the Asphalt framework and using the APScheduler within there.
Not much really. These projects are very separate. I want to have some integration at some point, but as far as async support goes in APScheduler, I didn't actually plan to go that deeply into async until I was requested to do so by Omar Katz of Celery, because they want to jump both feet into async. So I figured I could do that too, and just provide a synchronous interface for people who don't want to use async directly. This new async support will be centered around my other project called Any IO, which is a common API for doing async IO with Async IO, Curio, and Trio. You can use any one of these three as backend. NIO still doesn't support Twisted because of some architectural issues with Twisted, but I'm hoping that is an issue we can overcome at some point with Twisted people. So I don't know how to handle Twisted support. I think that APScheduler 4 will need to have a lot of pre-releases to sort out the design issues because it's going to break quite a lot of the interface because it's quite necessary. Some of the issues with the design are such that you can't really fix them without breaking stuff.
Are there any other aspects of the APScheduler project or dealing with task scheduling that we didn't discuss yet that you'd like to cover before we close out the show?
I can't think of anything. Oh yeah, there was one thing. There's a long-standing issue with using entry points that projects like Pi2X and PyInstaller have a problem with entry points because they don't package the library metadata, the distinfo directories, which breaks the entry points. And that has been a problem. I'm looking for an alternate solution, maybe giving up entry points completely. But it's been an issue that a lot of people have encountered.
And in terms of contributions or engagement with the project, is there any particular help that you're looking for or any particular skill sets that would be useful to you?
Well, not at this point, but going forward, it would be nice to have people contribute more backends to APScheduler once it's in a usable state.
Well, for anybody who wants to get in touch with you or follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes, and with that, I'll move us into the picks. And this week, I'm going to choose the Data Exchange podcast, which I found recently, that is hosted by Ben Lorica, who was formerly of O'Reilly. So he's moving the work that he had been doing with the O'Reilly Data podcast to his own independent one. And so far, it's been enjoyable. So if you're looking for a new podcast to listen to, I recommend taking a look at that one. And so with that, I'll pass it to you, Alex. Do you have any picks this week?
Well, there was this one library that I came across called Tenacity. It's a retrying library. It's very sophisticated and has full support for async too. It was a really nice find.
All right. I'll definitely take a look at that one. So thank you for taking the time today to join me and share your experience of building the APScheduler project. It's one that I've taken advantage of in the past, and so I appreciate all of your time and effort on that, and I hope you enjoy the rest of your day.
Thank you, and you are welcome.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.